Breaking something often requires you to know how that thing is made in the first place, unless you're using a sledgehammer. So today we will be dropping a carefully constructed payload into a website to crack it. Let's find out what the University of Michigan has in store for us as their hardest CTF web challenge. It seems to be a file upload challenge. You upload your text file with an Ascii image and it is stored on the server. Let's open Burp Suite to see all the details. You're familiar with file types, the TXTs, the EXEs, and the JAMs. A text file obviously can't do much. It can store your grandma's shopping list or maybe a few movies that you've been meaning to watch. But to infiltrate, we need something with more capability, more firepower. And since the website source code was written in PHP, that will be a great starting point to sneak by a payload. But before we do that, we should take a look at said source code to understand what security steps are being taken so that this site is safe. And don't worry, I'll simplify it for you. First of all, the file has to have a unique name, one that isn't already in the system. It has to not be too big, less than 50 kilobytes in size, and this next one is the main barrier. The file type has to be a text file. So if there is anything other than a TXT after the dot, the site will give an error. However, there's also a step which checks if there's a file type at all. Meaning, if there's no dot, we will just treat everything as a file name and simply not assign a file type. But how exactly do they check for a dot? Well, this line of code assigns a number for the position of the dot. And in programming, you generally start counting from 0, not from 1. So if this was the file we sent, the dot position would be 3. After that, this line lets the file type to be left blank if the position of the dot is null, or in other words, doesn't exist. Then it will equal false and the file let through. On the other hand, if there's any number, this will equate to true, and what's inside the if statement will be skipped. Now this is all well and good, but the developers missed one potential case: if the dot is 0. You see, in pretty much all coding languages, 1 equals true and 0 equals false. So if our file were to start with a dot, the position of the dot would be 0, and consequently, the website would pass this check and not assign a file type, which means we can send a file with any file format and any contents on the backend server. The only thing left to do is construct a payload. PHP was invented by Rasmus here in 1994. And to this day is primarily used to create websites that have a lot of functionality and moving parts, like online markets. Throughout the years, there have been a lot of patches and updates to PHP, and this is because it just keeps getting hacked. New vulnerabilities are discovered faster than a Chinese kid can assemble an iPhone. I mean, the php.net site itself was hacked in 2013. So even if you wanted to patch your version, you wouldn't know where to get it from if the official source is compromised. And to be honest, I don't know why companies still use PHP. It has had so many security breaches over the years and is still not the most stable platform to build a website server on. If you know why people still use it, please enlighten me. Interestingly enough, I've already seen this exact source code in another CTF challenge last year. So in classic university fashion, the organizers of this challenge copied someone else's homework. Anyway, from other files in the source code, we see that the flag we're searching for is most likely located through this path. So in our PHP file, we'll write some PHP code. We tell the system to cd, which stands for change directory, to this path, and then run the file called getFlag, which should display it on the front page. And this is mainly a proof of concept, because if we wanted to, we can run other scripts. We can extract any sensitive information, we can delete all of the files on the server and completely shut down this website for everyone else, all because of a missed 0. But we're not going to do that, because this is a challenge designed to teach what not to do and how to be responsible with your security practices. The only thing left to do is execute the file while it's on the server. To do this, we just copy the PHP session into the URL and try to open our PHP file. This will obviously run the script rather than read it, and we'll have our flag. So now that we put this challenge down like a dog, the next question is, of course, how do we prevent these breaches and not learn about it the hard way? First, file validation should never rely solely on checking extensions or positions of characters in a string. Instead, use a whitelist approach. Validate files based on their MIME type and inspect the actual content rather than just their names. Tools like this one in PHP can help verify that a file is what it claims to be. Second, always sanitize and restrict user input. In this challenge, the ability to upload arbitrary files led to remote code execution. Uploaded files should be stored outside the web directory, and the server should prevent execution of anything uploaded by setting proper permissions, or using a htaccess rule. For example, remove handler.php, .html, and so on. Finally, always assume attackers will find creative ways to break your system even if it seems airtight. And I'm not an expert. I'm still learning how to conduct security audits and penetration testing. These challenges are just a fun way to apply that knowledge. So I hope you learned something. PHP can suck my butt.